In wide area applications, the information measured over a wide area is transmitted to the control center and is used for power system state estimation, power system monitoring and warning, power system event analysis. So in power system state estimation, whatever the data is collected, that is angle, magnitude and angle of voltage at all bus bars in the grid can be estimated using a state estimation algorithm. Here in power system monitoring and warning, whatever the data, the phasor data, it will allow the operating conditions of the power system to be monitored on real-time basis. Okay, phasor data will allow the operating conditions of the power system to be monitored on real-time basis. So continuously it will be monitored. Okay, the real-time data. Okay, that is the system stability to be assessed, whether the system is stable or not. Okay, that should be assessed, and warnings generated. If any variations in the system, the warnings will be generated. Power system event analysis. So here synchronized phasor data of high accuracy is available before and after a fault or other network incident. Applications will be integrated into wide area monitoring protection and control system, that is WAMPAC, that is wide area monitoring protection control, that is future WAMPAC schemes, that is two schemes are there. One is to initiate actions to correct the system once a voltage, angle or oscillatory instability has been predicted. To initiate actions to correct the system once a voltage, angle or oscillatory instability has been predicted. So this may include switching of generators and controlling devices. Switching of devices and controlling devices means here such as FACTS and PSS, power system stabilizers, and HVDC converters. These three are used as a switching of generators and controlling devices. Here to generate emergency control signals to avoid a large scale blackout in the event of a severe fault. Okay, these are the two WAMPAC schemes. This is the figure you can see here, simplified representation of WAMPAC. That is, if you see here, all the phasor measurement units have connected. Totally it is 6 phasor measurement units, and here all the it is connected to the generation side, and here PDC, super PDC, all the measurements from the PMU, all the measurements will go to the PDC, super PDC. From there it will go to the state estimation, from state estimation to the online stability analysis. Okay, so and here state estimation to real time visualization of event to the control center. Okay, to the control center it will go. From the state estimation, here it will go to the control center. So state estimation, it will go to the online stability analysis. It will analyze if there are any variations, then it will give a warning signal to the real time visualization of an event, and this control operator should react to that warning signal. So here from the online stability analysis, it will also send the here control and protection purpose. Okay, so for where it is required. So these are the control signals and protection commands to the directly to the buses generation side. Okay, so from phasor measurements units, here FACTS devices are used. From phasor measurements we have directly sent to the PDC, super PDC. From super PDC state estimation to online stability analysis, from state estimation to real time visualization of event. Here system state, okay, system state, if any it will analyze if any warning or if any variations is there, it will give a warning signal to here, and the control operator will come to know that. And from online stability analysis, it will give directly control and protection actions, that is control signals and protection commands. Okay, this will go like this for a fax device and for the generator side. Okay, PMU, measurements collected from different network and state estimation used for online stability analysis. Here event occurs, its location, time, magnitude of generator or transmission and type identified. If any fault occurs, its location, time, magnitude of generator or transmission and type of which type of event is has been, it need to be identified. Real time visualization. Okay, real time visualization, that is replay several seconds after occurs. So here the online stability assessment algorithm continuously assesses the system to check whether the system is stable or not. If any collapse is there, if it is unstable, then it should be predicted, then the necessary corrective actions to be taken. Okay, so here next is online transient stability controller. So online transient stability controller using PMU, that is phasor measurement units, data and results from the state estimator, transient stability analysis is carried out repeatedly. Transient stability analysis is carried out repeatedly. You can see here real time measurements. So real time measurements, state estimation. From this data, the contingency stability analysis has been done. So that is what they are saying, using phasor measurement data and results from the state estimator. Here it is data, and here from this, that is data and results from this. Okay, transient stability analysis is carried out repeatedly, and the generator units, okay, generator units to be shed if a fault occurs are determined. So generator units to be shed if a fault occurs are determined. So real time measurement data is collected. Here it is carried out. Results from the state estimation, it is sent to the contingency analysis, stability analysis. It will verify whether it is a fault or whether it is everything is correct. Then if any fault in this it is identified, then generator should be shed off. Okay, fault occurs, the fault is compared with those contingencies identified before what the fault detection. If the fault detection, then it will be identified. After a fault occurs, the fault is compared with those of the contingency before what has been occurred. It will compare. Okay, it will determine the generator units to be shed. Then a signal sent to the local control units to shed the identified generator units. So these control signals, here fault detection, it will compare, and then after comparison, then it will be sent to the shed generators. Okay, remember like this: real time measurement, state estimation, RS, CGCS. Okay, CBCS syllabus like that. You remember CGCS. Real time measurement, state estimation, contingency stability analysis, generators to be shed, control signals, shed generators. This is a pre-fault operation, this is a post-fault operation. Fault detection, and from this what we get, that will be compared, and based on the comparison result they will decide the whether to shed or off or on. Okay, Slipping preventive controller. When a severe fault occurs in a power system, this controller would predict unstable conditions of the power system and rapidly trips an appropriate number of generator units or splits the system into two subsystems in order to prevent a pole slipping. So, if any severe fault occurs in a power system, this controller would predict an unstable condition of the power system. Rapidly, it will trip a faulted section or it will split the system into two subsystems in order to prevent a pole slipping.